Hello everyone, welcome to Lenin's lectures. Today we are going to learn module 3 of operating systems, which is CPU scheduling. In CPU scheduling, we have two types, which is one is non-preemptive and second one is over here, which is preemptive. The basic difference between non-preemptive and preemptive is that in non-preemptive, the processes do not repeat. It will only execute itself once, except for round robin. Let's take a look. So first one we have is this one, which is first come first serve. Here, what happens is that as the so I'll just explain like what are the acronyms here. So AT stands for arrival time, and BT stands for burst time. Here you can see that P1, P2, P3, P4, P5, they come at the arrival time 02468, and their respective burst times also given. So in first come first serve, you start with what comes first. So if you see in the Gantt chart, you can see that the P1 is coming first at 0, and then it executes from 0 to 3. Then the second process P2 is executing immediately. Then P3, P4, P5. To um, to work this out, you need to write this ready queue over here. So ready queue, what basically is that for it basically queues all the processes that come in according to the arrival time. So as you can see, at arrival time 0, P1 came first. Then at arrival time 2 itself, P2 came. But when P2 came, P1 was already executing because the burst time of it is 3. So it will wait in the queue, and when P3, when the time is equal to 3, the second P2 will execute over here. And then the rest of the process also the queue until the finish the until the P2 finishes his execution, which is 6. So 3 plus 6 is 9. Then you have P3, P4, and P5. Any doubts?
No.
ठीक.
Listen, will
Hmm.
you wait for 1 minute? I will write it down.
Arey, I'll share this file. No. Do you want to write it down right now?
अच्छा ठीक है.
I'll share this file with you.
ठीक है. When you do the GNA Gantt chart, na, just tell me. Like I'll note down that one.
So Gantt chart is here.
Like how to calculate this one.
Acha, I'll explain that. So see, first what we do is we first write the ready queue for this. So if you want, I will do this work this out again. So ready queue, right? Ready queue. So whenever you say arrival time, you have to write the ready queue. So which is like for t equals to 0, what process arrives at t equals to 0?
P1.
P1. So P1 with a burst time of 3. So you write that at t equals to 0. Now at t equals to 2, P2 arrives. P2 is arriving at
Burst time
P2
of
is arriving with
6.
a burst time of 6. But then P1 is already executing. P1 will execute until t equals to 3. So nothing will happen. P1 will continue its execution until 3. So then you will do t equals to 3, and then P2 equals to 6. Same. And now, if you see in the arrival time, you see that at t equals to 3, no other process arrives. So you don't have to write anything. And now this P2, it will continue its execution from 3 to 6. 3 From 3, it will take 6 more seconds. So you can directly write t equals to 9, which is 3 plus 6. And now you'll see that P2 got its execution over at 9.
mm,
And then if you now you can write the other processes that came between 3 and 9. So if you see here, for at P3, P3 came at 4, P4 came at 6, and P5 came at 8. So you can write here, since P2 is finished this process, you can write P3 equals to P3 of 4, then P4 of 5, and P5 of 2. So then you can just execute this here. Because it's first come first serve, what comes first, you'll do that. Since like all are coming like 0 2 4 6 8, you'll know that P1 P2 3 P4 P5 is the order.
mm-hmm.
Any doubts?
No.
ठीक. So now in this question, you will be asked to calculate this the for mainly TAT and WT. TAT is turnaround time,
Mm,
and WT is waiting time.
mm,
And this response time they also ask to calculate sometime, but mostly they won't ask probably. And the formula for TAT is TAT. I'll just write it with red. TAT equals to I think it's CT minus 80. Correct one, yeah. CT minus 80, and WT is equals to TAT minus BT.
how do you calculate response time though?
Response time I'll explain. I'll explain after this too.
Okay.
So I'll erase all this and we'll do this again. Hmm. So you already have the AT and BT of this from the question. Now we go to write the completion. CT is completion time. So
Mm,
completion time, you see for P1 here, it takes 0 to 3. So its completion time is 3.
mm,
And for P2, it takes 3 to 9. So the completion time is 9.
mm,
For P3, it's 13.
mm,
And P4, it's 18. And P5, it's 20.
mm,
This is the completion time. Now TAT is CT minus AT. So you have 3 here. You have 9 minus 2, 7. You have 13 minus 4, which is 9. 18 minus 6 is 12. And 20 minus 8 is again 12. Okay. Hmm. Then you have WT. WT is equal to TAT minus BT, which is for the first one is 3 minus 3, which is 0. For second one, 7 minus 6, which is 1. For third one, 9 minus 4 is 5. For fourth one, 12 minus 5 is 7. And fifth one is 12 minus 2, which is 10. Any questions so far?
no.
ठीक है. Now, the last one, response time. What you have to do is the formula is CPU get processed minus 8. Now, the CPU gets processed. It is same as completion time, but sometimes it's different. I'll explain when it becomes different. But you can take it as the same as CT, like just to verify. So CT is only equals to CPU gets processed if there is no idle time in between. When do you get ideal time? Suppose I'll just draw it here. Suppose you have P1 coming at arrival time of let's suppose 0 and burst time of 2, and P2 comes at arrival time 3 with a burst time of 1. So if you draw this Gantt chart of this, so write P1 here, 0 1, you'll write this for 2, right? And then but then P2 only comes at third second. So 2 to 3 it's idle. Then
Mm,
P2 happens 3 to 4. So this one is idle, the CPU is idle. So in this case, the completion time of P1 ka completion time will become 2, and P2 ka completion time is 4. But the CPU gets processed. It's basically what do you say? For P2 it's 3, and for P1 it's 0. Basically, this idle thing, it causes problems. So you take this CPU gets processed.
Okay.
Just keep that in mind that because of the idle time, the response time calculation becomes difficult. That's why we take CPU gets processed.
Mm.
Okay, I'll explain how to do that now. So for this, CPU gets processed for one P1 is 0. So like when does it start its execution of the particular process? So if you see P1 starts at 0, so you will do 0 minus and the arrival time. Arrival time is also 0. So 0 minus 0, you will get 0. We can do the same for the others. So for P2, the CPU gets processed as 3 and the arrival time is 2. For the next one, for P3, the CPU gets a process as 9 and the arrival time is 4. And then this is 13 minus 6 and this is 18 minus 8. If you do this, this is 3 minus 2, 1. This is 5. This is 7, I believe, 7. And this is 10. That is your response time. It's the same as WT, waiting time. This will not be the same in case you have a waiting, if you have a idle time in between.
Okay.
So that's your calculations. You do this table and then you have to calculate the average TAT and average waiting time, which is you take the sum of all the TAT here and divide by 5, and same thing for WT.
Okay.
That's it. That's your FCFS.
Okay. This is easy.
Hmm. The second one we have SJF. This is shortest job first. In the previous one, what we did was we took the process which came first. But in case of the second one, the shortest job first, we have to look at which job is the shortest. But according to the
Means
arrival time, because there's arrival time also.
I didn't understand which job is the shortest means which has the shortest burst time.
Yes, burst time basically.
Okay.
Huh.
Is it preemptive or non-preemptive?
This is non-preemptive. So how do you understand what is non-preemptive and what is preemptive? Non-preemptive, the Gantt chart, the processes will repeat itself, but in non-preemptive, it doesn't repeat itself.
Okay. Okay.
So what happens is in preemptive, whenever a process comes like at t equals to 2, it will interrupt the CPU and checks if that has higher priority or not. Should it execute or not? It basically interrupts every time a new process comes. But in
Okay.
case of non-preemptive, it doesn't interrupt the CPU. The CPU will continue execute the current process, then look into if there is a new process, should it execute it or not.
Understood.
So let's work this out. I'll erase this again. So see, ready ready queue at t equals to 0. So t equals to 0, you have p1 of burst time 3, and so you can execute that directly here, the Gantt chart. First one is 0 to 3. Then you can now check at 3. T equals to 3. You have P2 of burst time 6. So now you will execute P2. Then you will should check at 9. So when you go to 9, you'll see that at 4, 6, and 8, three processes came, right?
Hmm.
So you'll now arrange it according to the burst times. So if you see, P5 has the shortest burst time of 2. So you'll write P5 of 2, then P3 of 4, and then P4 of 5.
Mm.
This is the core of the shortest job first this algorithm. Where like at 9, right, when it came at t equals to 9, three processes, they are already in the queue together. Now you have to choose the shortest process to be executed first.
Okay. Okay.
So P1, P2, it came before all others. So they had no choice. But when t equals to 9 over here, you have three processes. And here you can choose the shortest process, which is P5.
Okay, Lenin, I have a doubt.
Hmm.
Um, in the first question, the
Mhm.
FCFS, we have considered the residue while taking t as arrival time, like t equals to 0
Huh.
to um, like this. But my doubt is that I'm not understanding how did like t equals to 3 and t equals to 9 come to place in here.
Huh. See, so because what is it? This is because this is non-preemptive. We don't have to write for every single one. That is for t equals to 2, P2 came. Um, then for t equals to 4, P3 came. Then t equals to 6, P4 came. We don't have to write all this because this is preemptive. So we jumped from 3 to 9 directly because you see that the burst time of 2 is 6. So any process, even if any process comes during the execution of the current process,
Hmm.
huh, any like the because the burst time of P2 is 6, even if any other process comes, it won't execute, right? Because P2 is currently executing. So you can directly jump 3 plus 6 equals to 9.
Hmm. Okay.
Make sense?
But one thing I didn't understand is that you considered for t equals to 0. Then you considered for t equals to 3. But arrival time of P2 is t equals to 2. Then why did you consider 3?
Because the burst time of P1 is 3, right? So
Okay.
at t equals to 2, you will get P2 of 6. But then if you see in the CPU, in the like here, Gantt chart, you'll see that at t equals to 2 over here, P1 is still executing. So it's meaningless.
Okay, okay, okay. Understood. Acha, listen now. Can you show me the first question once again?
Sure.
Just one correction. It just. Acha, tell me in here, t in t equals to 0, p1 is 3,
Uh-huh.
and its burst time is 3.
Hmm.
So why did you write t equals to 2 pay? P2 of 6 will come.
I just wrote to show that, but we are not doing anything Gantt chart. You can show
Okay, okay,
everything, but you don't have to. This is
okay,
basically an extra step here.
okay, okay. Understood. Now I'm getting it.
Okay. So this is now your Gantt chart. So we were here at P5 of burst time 2. So you will take the shortest job from here, shortest process. So P5 has burst time 2, so we'll first take that. Then P3 has burst time 4, so we'll take that. Then last comes P4 of burst time 5.
Okay.
This is your shortest job. ठीक है, any questions in this?
No.
ठीक है. I'll not do every calculation here, but I'll just um, write the completion time because the order is not the same. Order is not P1, P2, P3, P4, 5. You have to be conscious when you are like filling the CT. Otherwise, or everything will go wrong. So for P1, the completion time is 3. For P2, the completion time is 9. And then after P2, P5 is executed, right? So we'll write a P5 first. P5 is completion time is 11. And then P3 is 15 and P4 is 20.
Okay.
Okay. And then same calculations TAT, WT, and response time, and average TAT, average waiting time.
Uh, Lenin, 1 second. Can you show me that chart again? The above chart.
Which
This
one?
one. Here. Just keep it on hold.
Hmm.
Acha, so first P1, you have taken it as t equals to 0 arrival time. Then P1 ends in 3 seconds because the burst time is 3. Now P2 starts, who's having an arrival time at t equals to 2, and it stops at t equals to 9 because its burst time is for 6 seconds.
Yes.
And after that, you are telling me that since arrival time of P3, P4, and P5 are in between 3 and 9, this is why they are like scheduled in a queue. So whichever is having the shortest burst time will be executed as soon as the P2's execution ends. Am I right?
Yes.
Okay, okay. So 2 seconds is 11, and then again 4 seconds is 15, and okay, okay, got it.
Okay, done.
Hmm.
And then we have third one. So we did FCFS and SJF. The
Hmm.
third one is priority. So the priority is same as FCFS, but only thing is you have an extra column. So I'll just show that. For example,
Lenin, I have another doubt.
hmm,
What if there is another process called P6 and its arrival time is t equals to 10? So will it be the last one to execute?
wait, let me see that. Okay, here, right? For
Yeah,
SJF. So if we have P6 with arrival time of 10,
yeah.
um, we can have it after at T equals to 11, right? We can check the ready queue. It will depend on the burst time for SJF.
Acha, acha.
So if the arrival time is 10, so what you suppose the arrival time, I'll just write it better. Suppose the arrival time has P6, 10, and the arrival time, suppose the burst time is also 10. It takes the longest. So what happens now? Here P5 is taking 2 seconds. So 9 plus 2 is 11. At T equals to 11, sorry, T equals to 11, you will see you have P3 of 4, P4 of 5, and then P6 of 10.
Okay, okay.
But in case like P6 was 1, suppose instead of 10, it will become 1, and the next thing you will execute after P5 is P6.
Okay. So, okay, okay. Understood. So, like, once if something like arrival time 10 seconds or anything comes, we will check in the ready queue
Yep.
that whether it is inside the process time or not. Understood. Hmm.
Okay. So the third one, which is priority, what happens in priority is you have a priority, and let's suppose let the priority be 1 2 for this, and let's suppose priority for P3 is let's suppose for P4 it's 3, then 4 here, then 5 here. So what happens is here you won't in SGF we looked at the burst time, right? For ADQ, when you have to decide here, when multiple processes are in the queue, we decided based on the burst time. But in the priority case, we will look for the priority directly.
Okay.
Just show that. So goes here. Okay. So here instead of this order, what we'll do is now P1, P2 is executed because they came first before others. At T equals to 9, all the other processes are together. But you have to now see the priority. So if you see priority of P4 is 3. So you will write P4 of burst time 5. Then you have priority 4, which is P3 of 4. Then you have P5 of 2. So in the Gantt chart, you will get P1, P2, P4, P3, P5.
Lenin,
Hmm.
I have a huge doubt. Which
Yes.
which question is it?
This one is priority.
Only priority.
Yes.
Okay. So is it priority non-preemptive or preemptive?
You can have both preemptive and non-preemptive. This is non-preemptive priority.
Acha.
Hmm. So in this, what happens is you will be given a priority column. So in the last question, we at t equals to 9, we chose based on the burst time, right?
Hmm.
Based on which is the shortest burst time. But here the priority is directly given, which is 3, 4, 5. So you'll take P4 has priority 3, P3 has 4, and P5 has 5. 3, 4, 5. So you take that order.
Okay. But did you check, like in my DA, it was written that the higher priority has the lowest uh, arrival time or something.
Oh, it depends. Okay, so priority, no. Priority you can take 1 to be the highest or 5 to be the highest. You can choose which one, whichever you want.
Okay. What if I consider as like consider this situation where the
5 has the higher
highest,
priority.
highest priority is the having the lowest arrival time.
1 has the lower priority, right? So when 5 has the highest priority and 1 is the lower priority, let's see. Because even though these are of lower priority, according to the arrival time, they are coming first. So we have to take them first. And after that, if you see in the last one only, you are getting P4, P3, and P5. So here now you will execute P5 first, then P3, then P4, because this has the priority 5, this is 4, this is 3.
Mm.
Okay, so your
So
Gantt chart will
initially,
become.
uh, my question is that initially we will check the arrival time. Once,
Huh.
once they once suppose in this case t equals to 9, at that time we are going to check if the burst times of the other processors are included in this time range or not. If it
Hmm.
is, then we will schedule it using priority. Is this
Yes,
how we are gonna do it? Okay, okay.
that's priority.
Hold on,
And
I'm noting the process down.
okay, so this is for the 5 being the highest and 1 being the lowest. Or you can take any. You can take one to be the highest also. You just have to mention in the paper which way you're taking.
Lenin, when
Hmm.
you checked that t equals to 9, and did you check the arrival time of the remaining processes, or did you check the burst time to see if they are like falling in the range?
Falling in which range? For or like at t equals to 9.
Yeah, yeah, yeah.
At t equals to 9, you check the arrival time, right? You see that 4, 6, 8, they are in between of 3 and 9.
Okay, okay, okay,
Hmm.
okay. Done.
No, let's move ahead. Now, the final one, non primitive, is RR, which is round robin.
Okay, Lenin, I'm very sorry. Can you show me that once again? Just for one
Hmm.
second. Very, very sorry. We considered one as the lowest priority and five as the highest priority. Right.
Yes.
Acha, tell me, in our DA, there are like in the question sets it's written, assume lowest priority holds the highest priority level. What does it like? What does it mean?
Lowest priority level holds the highest priority. That means lowest priority level is probably 1,
No,
right?
lowest priority value, that is one.
Value.
One, one.
Holds the highest priority. So 1 will the highest.
Okay. So if this happens, then then P4 will be priority
First
4.
executed.
Okay,
Huh.
P4. Will you do the Gantt chart in with respect to that, just for clearing the
Uh,
confusion?
sure. So here P1, P2, this will be the same. And then if you see P3, P4 has 3, right? So you will do P4, then P3, then P5. And I'll write the priorities also. This is priority 1, 2, this is 3, this is 4, this is 5. This is 1, this is 2, this is 5, this is 4, this is 3.
Okay, okay, okay. P1, P2. Hmm. Okay, done.
Okay. So we move on to the next one, which is RR or round robin. In round robin, what we do is the processes you'll be given a quantity which is time slice or time quantity. Both are the same thing. Time slice slash time quantum.
Hmm.
This will be given to you for round robin. What it basically means is that in round robin, the CPU breaks down each process into this particular time slice. So if you see in the Gantt chart, you can see, right, every process is only going for 3 seconds maximum.
Hmm.
Can you see this?
Hmm.
So that
Yeah.
is round robin. And
Okay.
how do you do this? For this, you can take the priority to be the to be 1, 2, 3, 4, 5 like this. There is no arrival time for round robin as such. And even if there is round this arrival time for round robin only comes in preemptive. For non-preemptive, arrival time won't come.
For
Okay.
preemptive, there might be arrival time. Acha.
Huh. So for this, you can directly do the Gantt chart. And wait, let's do the Gantt chart actually.
Listen, Lenin, are
Hmm.
these sums from my DA?
No, this is from my notes.
Acha, ठीक है. You send me this file later.
Okay. Okay. So see, we'll first start with P1 here. The P1 goes from 3 to maximum 0 to 3. Because the burst time is 10, you have 7 left after this. So I'll just write 7 here. Great. And then we have P2. P2 ke liye, we again go for 3 seconds. So 3 plus 3 is become 6. And 8 minus 3 is 5 seconds is left for P2 now. Then you go for P3. P3 has burst time of 3 only. So 6 plus 3 is 9. And this left is 0. So
Hmm.
basically P3 is done now. Then you go for P4,
If,
which is again 3 seconds. 9 plus 3 is 12.
hmm.
And what is left for P4? 1 is left because 4
1.
minus 3 is 1. And then P5, you go for maximum 3 seconds. Oh, sorry. So 12 plus 3 is 15. And what is left for it? 3.
Hmm.
Now you repeat this circle again. That is round robin. You go round again. So now you have P1 again.
Using the same P1, P2, P3
Yes.
in the same order.
Same order.
Acha, Lenin, what if, like in this chart, they have given process ID 1, 2, 3, 4, 5 serially? What
Hmm.
if in the exam hall we get questions like process ID 1 and then process ID 4, then process ID 5, then process ID 2? Then what should we do in this round robin case?
You can take it chronologically 1, 2, 3, 4, 5. Even if they have given it jumbled, you can
Okay,
either take that way or you can take it the same order that's given there.
okay. It
Okay.
doesn't matter.
Hmm.
Understood.
And then now P1, how much was left? So 7 was left.
7
So
minus 3.
7 minus 3 is 4. The 4
Yes.
will be left here and you will write 18. And then you do P2. P2, 18 plus 3 is 21 and 5 minus 3 is 2 is left. Now, if you see P3 already got over, so it won't repeat again. You will directly go to P4 now.
Okay.
And P4, if you see, there was only one left in the last cycle. So you'll just do only one second of the execution. So you'll write from 21 to 22. And
Okay.
this becomes 0. This P4 is done.
Okay.
Now you do P5. P5 only 3 was left. So P5 is also done now. 22 plus 3 is 20. 22 plus 3, 25. Yeah. And this becomes 0. So P5 is also done. Now what is left? P1 and P2 is left. So P1 only 4 is left. So 1 will be left over now. And 25 plus 3 is 28. For P2, P2, right? Yeah. For P2, only 2 was left. So this becomes 0. And 28 plus 2 is 30. I'll just erase this. Oh no. Hmm. And then again P1 is left now because P2 is also over. Only P1 is left, which is P1, and only 1 second is left. So this becomes 31,
31. Okay.
and this, and P1 is also done.
Okay.
So this is your round robin algorithm.
Okay. Okay. This is the non-preemptive one, right?
Hmm. So if you see, this is one cycle, this was second cycle, this was third cycle, this was fourth cycle.
Okay.
Okay, this is done. And then same thing, you find the uh, okay, for TAT and WT, you'll have to do, like, be bit careful here. Um, issue is you have to look into the completion time of the process. So because it's going round and round, you can only take the completion time of when it actually got completed. So for P3 it was 9, but then for P1 the completion time is 31.
Okay.
So you have to take the appropriate number. So for P1, P3 it's 9, which is here. Then for P1 it's 31. For P2 it's 30. For P5 it's 25. And for P4 it's 22.
Sorry, but I
Oh,
suddenly
no issues. Hmm. So only a saying ki, oh, take care of the completion time here, which is these numbers. And then rest are the same calculations.
okay.
Any doubts?
Uh, wait time is अच्छा wait time is ठीक है only for uh, का, का,
Completion time.
CT. Yeah, CT we need to be careful. Understood. Acha, why did you subtract all of them by zero? Oh, because the arrival time is not given.
Now,
Okay. Hmm.
I'll move on to the next one.
Mm-hmm. Sure, sure.
Now we have the primitive one. In primitive, all the processes repeat itself, can repeat itself. So if you see in the earlier ones, for example, SGF and FCFS, you saw in the priority one, no, none of the processes are getting repeated. But when you see in the primitive one, they'll get repeated. Let's see this example. So this is SGF with primitive, or the another name for this is SRTF, which is shortest remaining time first. So we have same P1, P2, P3, P4, P5, and you have the arrival times also. So you can see this note here. It says that whenever a new process comes, stop the current process and check the shortest job first in the ready queue. Okay.
I'm not understanding one thing.
Hmm.
Uh, I'm so sorry. The thing is that you have written SJF with preemptive and again SRTF. I didn't understand that.
It's the same name. It's an acronym for this.
SJF is shortest job first, right?
That is shortest job first with preemption, And the another name for shortest job first with pre-emission is shortest remaining time first. You have to
Oh,
remember that.
okay, okay.
Hmm. So the rule for this is this, which is whenever a new process comes, stop the current process and check SDF in ready queue. So let's work out the ready queue again here. Hmm. So for let's write a bit bigger here. Hmm. For t equals to 0, we have a P4, right? P4 with a burst time of 6. And normally in the non-primitive, we would directly write P equals to 6 and then we would write the other processor, right?
Hmm.
But here you won't do that because it's primitive. That means that whenever a new process comes, the current process is interrupted. So the next process, as t equals to 1 comes, which is P1. No, P2. So P2 comes with a burst time of 5 and P4 is already there. But since it has executed from 0 to 1, now the burst time is 5. Okay. Any doubts here?
Now, one second. Can you explain t equals to 1 once again?
Huh. At t equals to 1, P2 came, right? P2's arrival time is T1, 1.
Hmm.
So you write P2 of 5. And then P4, the burst time at T equal to 0 was 6. But it has already executed 1 second. So it will now become P4 of 5.
Acha, acha.
Hmm. So now you can see that P2 has burst time 5 and
Hmm.
P4 also has burst time 5. And our algorithm is shortest job first.
Hmm.
So it should have been in the other order. P4 of 5 and P2 of 5. Hmm. So now you see the numbers are the same. This P4 also has 5 and P2 also has 5. So here you will continue the same P4 here.
Okay,
Let me just
okay.
check once. Um, Primitive. Okay, correct one. Which is you have P4 of 5 and P2
Hmm.
of 5. So since P4 was already executing, you will continue that execution since the burst times of the both are the same.
Hmm.
And then now at T equals to 2, you have P4 of P4 of 4 will be there because one time has been executed.
Hmm.
Now a P1 came. So P1 came with a burst time of 1
Hmm.
and P2 is already there in the queue with burst time of 5. So yeah, now you can see that P1 has only 1 the burst time. So since we are doing shortest job first, we are going to take P1, which is here.
Acha, listen now.
Hmm.
P5 is also there in the arrival time of 2. Why didn't we consider that?
Oh wait, I didn't write that. I didn't see that. Sorry. So we'll write that also. Sorry.
Okay.
Uh, what happened? Huh. So for P5 comes the burst time of 3. But
Okay.
since the shortest one is P1, we'll take P1.
Okay.
And now, since P1 only has 1, now again it will at T equals to 3, it will check. So P4 is there at 4, P2 is there with 5, and P5 is there with 3. Now in this, the shortest one is P5.
Hmm. So
So now
P5.
you will run P5. But you will when you're running this, you see that it will go from 3 to 4 because at arrival time 4, P3 is coming.
Okay,
So
okay,
whenever a new process comes, you have to interrupt the CPU. That is why it's only executing 3 to 4 here.
okay,
So 3 to 4, P4 at 4 is there, P2 of 5 is there, and P5, it was 3, right? It becomes 2 now because 1 has been executed. And you'll see P4 at t equals to 4, P3 came, right? P3 with a burst time of 1. So now you will run P3 here because the burst time is 1. So run that, P3 gets over also because it has only one burst time. Now you will go back and do the SGF, that's it. The normal SGF, because now every process has arrived. So at 5, you will see P3 got over. You have P4 of 4, you have P2 of 5, and P5 of 2 is there. So now you will run P2 for 2 seconds directly, and this will get over. Wait, this will get over. Then after that, at 2 seconds, right? P5 takes 2 seconds. So at t equals to 7, you have P4 of 4 and P2 of 5. Now you will take P4 for 4 seconds directly. 7 plus 4 is 11. So P4 also gets done execution. And then at t equals to 11, you will have P2 of 5. And you will execute that, and that is also done.
okay, okay. So once all the processes arrive in the ready queue, we are going to do the non-preemptive version.
Yes. In preemptive, the only difference in preemptive and non-preemptive is that in preemptive, whenever a new process comes, you'll
Hmm.
have to write the time interrupt the CPU. So this Gantt chart is basically the CPU. And
Okay,
whenever a process comes at the arrival time, you have to interrupt it here, like this, and then check in the ready queue again. Which process has the least burst time.
okay, understood.
That's it. And then same calculations what we did before. I didn't write it here, but same thing. We do the completion time.
No,
Uh,
you don't have to write this. I just want to know the gadget. Acha, listen na.
hmm,
The completion time again will be the final time of the processes, right?
yes.
Okay, okay, okay. That's
So for P5, if you see, P5 is executed here also, but we'll take 7 because
hmm,
that's when it's completed.
hmm.
So
Okay,
SGF also done. SGF is preemptive. Now
okay.
we have the next one is preemptive priority schedule.
Hmm.
Here, what happens is you have to look at the priority here. How will you do? Let's see. Um, just put it up and have t equals to 0 to have p1 of priority 3. So here in the bracket I have written priority instead of the burst time. You can write anything. For convenience, I wrote the this first, the priority.
Okay, okay.
Hmm. So how does this one work? Let's see. So first we go with the arrival time, how we always start. At t equals to 0, P1 comes. So there's no other process is t equal to 0.
Hmm,
So you will start that execution here in
hmm,
the Gantt chart, which is
hmm.
for 1 second it ran. Because at arrival time 1, P2 is coming. So you see here P2 has a priority of 4. 3 and 4 is there. So since
mm,
3 has the higher priority, you will again run P1. And how long will you run? You will run until the next process comes, so just P3. And you see that P3 comes and its priority is also 4. So we'll just put it here. In case if the priorities are the same, you will take the process which has the lesser ID number, which is P2.
okay,
But since like the priority of P1 is 3, which is higher than 4, you will still continue to execute P1 here at
okay,
3. So now at t equals to 4, P4 comes. P4 has the priority 5, so you will write it here. Again, P1 has the highest priority so far here. So now you
mm,
will continue executing here and you come to t equals to 5. T equals to 5, you get P5. P5 has a priority 2. So now you see it has 2. Since it has 2, P5 will run now, which is here. Sorry, here.
okay,
At t equals to 5, we got P5 of priority 2. So we'll continue to run this.
mm,
And again at t equals to 6, a new process comes here, which
mm,
is P6. And P6 has 6, which is the lowest priority. So it doesn't matter. You can continue running P5 again. So now you can run until t equals to 10.
mm,
So you see at t equals to 10, P7 comes with the priority of 1, which
mm,
is the highest priority. So now you will run P7 first. It has only burst time of 1. So P7 is done. And then you have all the, after that, you can just write at t equals to 11. You can write the same thing, everything that's there already.
okay. Acha, listen na. We
Hmm.
are like simultaneously once we place a processor in the Gantt chart, we are also going to calculate and reduce the burst
But
time,
time.
right?
Yes, yes, yes. I haven't
Okay.
shown that here.
Okay, okay. Understood.
So now you see that P7 is done. Now you have the next highest priority is 2, then 3, then 4, then 4, then 5, then 6. So
Oh,
you have you do the normal one then. So P5 has burst time of 1 here. Sorry,
mm,
here is P5. P5 here. P5 we already executed so many times, which is we executed 1 second here, 4 seconds here. 5 seconds are done.
mm,
So you have 1 second left, which is which they are we are doing 11 to 12,
mm,
and then after that we are doing P1. P1 also we ran 0 to 5 here.
mm,
So 5 seconds we ran, and P1 had burst of 8. So
mm,
we had three more left. We are doing three more here. 12 plus 3 is 15. And
mm,
then same thing for P2, P3, P3 P4, P6. Like once all the processes come into the ready queue, we just do according to the priority.
okay. Non-preemptive, right?
Yes.
Okay, okay. Okay, got it. Hmm.
And
Acha,
then
then,
say, ha.
yeah, tell me.
No, I'm saying here also you have to be careful about the completion time. So you see,
Okay,
P6 is completing here, P4 is completing here, P3, P2, P1. Is there anything else left? P5, right? P5 is executing, getting finished here. P7 is getting finished here. So you
hmm.
have to take these completion times.
Okay, understood.
You have to be careful about that.
Okay, understood.
And actual calculations are same. Any questions?
No. One question is that we don't have any. Do we have any preemptive of first come first serve?
No, we don't.
Okay, okay,
It's trivial because let's see. First come, first serve, right? It is according to the arrival times only.
hmm.
So that's the what comes first, you will take that first. So even if let's see here, right? T equals to 2, P2 came, but P1 is already executing. It came first, so there is no meaning of it doing it again. Why does it have to interrupt itself when you know that P1 is going to finish itself?
Mm-hmm. Got it.
So FCFS primitive does not exist.
Okay.
Any questions in priority primitive?
No.
T. And then you have the final one, which is round robin with preempt. So in round robin, you have to be careful. So here I've written this, that in round robin, whenever a new process comes, right, you won't interrupt until the slice is done. I'll show you how it works. Let's solve this also. Uh, I'll take this on the right side because I wanna refer this.
Can you tell me the instruction that you gave me right now again?
Wait, I'll tell you. I'll tell you.
Mm.
Okay, let's do it here. Let's try to solve this. So ready to t equals to 0. We have P1. Here we have arrival time. Last time when we did round robin, we didn't have arrival time, right?
Mm-hmm.
But this time we have arrival time. So we have to do the ready queue. We have to be careful here. So see, P1 comes first at t equals to 0 with a burst time of 8. And now you will run this for 3 seconds. So now you will go for t equals to 3. I'll draw the Gantt chart below here. So first P1 runs for 0 to 3. In the question, time quantum is given 3. Time quantum equals to 3. So P1 0 to 3 it goes. And then, but then if you see, like P3 comes at arrival time 1.
Mm-hmm.
T equals to 1, P3 comes with arrival burst time of 7. So when you can write that, but you won't interrupt the CPU because P1 is already executed.
Okay.
And now at t equals to 3, you have P3 of 7 and then P1 of 5. Now
Okay.
you will take P3 here. So P3 and it will execute for 3 seconds.
Why did you take P3?
Because it's round robin, right? It goes from P1, P2, P3, P4, P5.
Okay, okay.
So, but there, since the other process are not there, you will take what's the next process. After P1 is P3, and then again suppose no other process comes after 3 seconds. So again P1 will be executed.
Okay.
So now let's see now. So T equals to what is it? T equals to 5, right? Because P2 is coming at real time 5 here.
Acha, हाँ. हाँ.
The T equals to 5, P2 comes with a burst time of 2. And then you already in the queue you already have P1 with a burst time of 5. So you'll write that right below like that. Correct, right? Mm, TP5, P1, P2. Oh, P1, then P2 will come. Okay, that's a mistake I did. That was what was looking. So you have to in this the order is very important. So I'll start this again. At t equals to 3, we are executing this one P3 of 7.
Hmm.
Okay, so we took the Gantt chart here, which is P3, it goes from 3 to 6. And then now at t equals to 5, you already have P1, right? from
Mm.
T3. So you'll write this P1 of 5. We are not writing the P3 because P3 is currently being executed. If something is being executed currently, it won't be the queue, right? It will go to the CPU.
Okay.
So like, see this, right? This is the queue. It goes like this. You have the CPU here, CPU, and then it comes back to the queue like this. How does the queue work? It's first in, first out, right? First
Yeah.
in, right? First in, first out. So whatever
Yeah.
comes in, it goes to the back of the queue. That's how you have to imagine this queue also. How see? So P1 first was there here, and at t equals to 1, we are not writing P1 here because P1 went from here to the CPU, from the queue to the CPU. And then t equals to 3, you see that P1 stopped executing. You see here
Yeah.
that P1 stopped its executing at 3. So you'll append it in the end of the queue, which is P3. P3 came, then P1 came. And at t equals to 5, P3 went to the CPU. So the first spot became empty. P1 came forward. So now P1 of 5 is there. And then
Achha,
you
why
see that
did P3 why did P3 go back to the CPU but P1 didn't?
because we are doing round robin, no?
No, but P1 is also in the cycle, right? So since it's executed already once, it should go back to
Ha,
the CPU.
look. I'll draw the queue, okay? So for t equals to 0, okay? We have
Mm,
the P1 in the queue.
mm,
Suppose this is a queue and this is the line to the CPU.
mm,
And this comes back here. So at t equals to 0, the queue is empty. P1 is free to walk into the CPU. At
mm,
t equals to 1, you see that P1 went to the CPU. P1 is here in the CPU,
mm,
inside the CPU. And the queue is again empty. So P3 came and it went to the, it's waiting for P1 to come out from the CPU.
mm.
And then when t equals to 3, what happens? P3 is here waiting, and P1 is P1 is just coming out. So CPU is here, and then P1 is just coming out here like this. Do you understand?
Mm.
It's coming out from the CPU, right? Because 3 seconds is over for P1. It only has the limit of time quantum 3.
Oh, okay, okay. Now I got it. Yeah.
So when what happens when 3 equals to 4 happens? 4 no 5 right? T equals to 5. We see that the Q P1 came from the end of the line again. So P1 now is here and P3 is inside the CPU. And then when it's inside the CPU like this, you see that P1 came at P1, P1, oh no, P2. So P1, P2. Oh, yeah, I didn't write it here. So P2 came with a burst time of 2. You see
Mm,
this, right?
mm,
Here, P2 came at arrival time 5. So P2 is coming from outside. He see the queue. So he will come over here, right?
mm.
That's how you write the queue.
Okay, got it. Now I got it.
So let's go back here. So you see at t equals to 5, P3 went to the CPU. So that's why he is not in the queue.
Mm,
And then P1 was already in the line, so P1 came forward. P2 is behind P1, and then
mm,
at t equals to 6, you see that P1 is there, P2 is there at 6. At 6 now, see, here is the issue now. What happens is at P4 6 at time 6, P4 is coming from outside, and
mm.
I'll draw the same thing, the Q and the CQ thing. Let's see. Um, Suppose this is the queue. This is the CPU, and here what was executing at t equals to 5? P3 was executing, right?
Mm.
So
Yeah.
it has to come back from the CPU to the queue, and it has P1 and P2. But
Mm.
then from outside, we are getting one more process, which is P4, a new
Mm.
process. So now you have to decide which is going to the queue first. Will it be P4 then P3, or will it be P3 then P4?
Okay.
And this one, um, what happens is the outsider first comes and goes to the queue, stands beside P2, and then the CPU, the person is coming from the CPU, he's coming to here. So this becomes P4 and then P3. Just assume that it takes more time to come back from the CPU than for a new person to come in the queue. It's a bit confusing. Wait. See, we are choosing P4 to come here because, for example, you just went and played a game, and one more new person is coming with you, but you just played a game, so you can be like, "Oh, I just played. You can go ahead from me."
Mm. Mm. Okay, okay, got it, got it. So, like, we are going to give the preference to the newcomer.
Yes.
Is it like for all the cases in this preemptive round robin?
Yes. All the new people who come, they'll be given preference over people who are coming back from the CPU.
Okay, so the oldest processor will be given the preference at the end.
Yes.
Okay, okay, got it.
So here, a t equals to 6, right? We had this issue. So now we will write P4 with the burst time of 3, and then the returning process, which is
Hmm.
P3, with a burst time of 4 now. It was 7 here, took 3 seconds. So it becomes 4 now.
Hmm. Hmm.
Wait, I'll just erase all this. I'll just push it back a little. Yeah, I'll just delete all this. Hmm. So just keep in mind that this is the newcomer
Hmm.
and this is the returning
Hmm.
from CPU.
Okay, got it.
And same thing here. The P1 here was the returning from CPU.
Okay, okay.
Hmm. So let's draw the Gantt chart simultaneously.
Hmm.
So let's see. At t equals to 0, P1 came. So it executed for 3 seconds. At t equals to 1, P3 came.
Hmm.
But then we are not going to interrupt the CPU because this is round robin. And time quantum is more important than interrupting the CPU here.
Hmm.
So P3 is execute then T equals to 3. P3 is in the queue and the returner, which is P1, he executed 3 seconds and came back. So now he's next in line from P3. So P3 is getting executed, and then T equals to 6, because of 6, right? We have P1, the next one, if you see. So P1, and you do this for 3 seconds, which is 9. Then we haven't finished the ready queue yet because if you see, P5 is still yet to come. So let's first do that. So now from 6 to 9, P1 is executing, right?
Let me hold on.
Hmm.
we should be planning
Hello.
planning from 6 to 9 P3 will
Yes,
be
I can hear you now.
executing, right? Sorry,
6
sorry,
to 9
P4 will be
P1 will be
executing, right?
executing.
The newcomer will be executing.
Hello.
Hello, can you hear me? I'm
For
if I'm not wrong.
I can hear you now. Yeah, yeah.
Hello. Oh, sorry. I was asking कि since at t equals to 6, P4 is the newcomer, so P4 will be preferred the most,
No,
right?
no, 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 no. It won't be preferred the most because if you see the queue, right? P1 and P2 were already in the queue. So if you are standing in
Okay.
line already, you won't let a newcomer just cut the line, right? You have to wait back in the line. But if two people are coming in together, then the newcomer will be given a preference. Oh. Hello. Can you hear me?
I
Hello.
was hello.
Ha.
Okay, I was saying कि can you help me understand how to write the priority in the ready queue?
Yeah, yeah, yeah. That's what. So I was explaining here, right?
Hmm.
You had confusion with the newcomer, right? P4.
Hmm.
So see what happens. So if you see before the newcomer came, um,
Hmm.
the queue had P1 and P2 already at t equals to 5. Okay.
Okay.
So let's draw this. So this is the queue, this is the CPU, and this is at t equals to 5. So you had P1 already, P2 came in new, P2 came
Okay.
in, and this is the queue. And inside the CPU, I believe P3s are getting executed. You see P3 was here, that is getting executed from 3 to 6. This one. So P3 is inside the CPU. Okay. Now at t equals to 6, you see a newcomer is coming which is the new process coming, P4, right?
mm,
P4 is a new process that's coming in, and P1 and P2 are already there in the queue, and P3 just got out of CPU.
okay, okay.
P3. So when now you see that P4 and P3 are clashing, they're basically coming together at the same time
Mm,
because P3 is returning and P4 is a newcomer. So when P4 is a newcomer, uh, P4 will go ahead of P3. So what will happen if you see the queue like after the split second, you see that becomes P1, P2, P4, and then P3
mm,
because the old guy will let the newcomer ahead of him, but P1 and P2
mm.
won't let him P4 cut the line, right? They are already waiting.
Yeah,
So that's what we are doing here.
yeah.
If you see, that's what we are doing.
Mm,
Um, P1 and P2 are already there in the queue here, and they are same in the next P equals to 6. They are the same. P1 and P2 are there, and then P4 and P3 came together. So P4 came here, and P3 stood in the last of the line.
mm. Okay.
Okay,
Mm,
let's not complicate that. Just imagine that whenever process is coming from the back from the CPU, they stand in the
mm.
last of the line always.
They stand in.
Last of the line.
Okay, okay. And before that stands the newcomer.
Yes.
Okay, got it, got it.
Just remember that. So I think that would be easier.
Okay, okay,
So
got it.
let's go back.
Mm,
So at t equals to 8, now t equals to 6, right? So 6 to 9, you see P1 is in the first queue at t equals to 6. P1 is at the first position. So we will execute P1.
mm,
So then t equals to 8, we see that P5 is coming. So what will we do? P1 is already gone to the CPU. P1 is not there in the queue anymore. So we'll write
yeah.
P2 with a burst time of 2. Then we have um, we have P4 with a burst time of 3.
Mm.
And then we
And then
have
P3.
P3 with a burst time of 4. And then we have P5, which is the newcomer,
Mm,
with a burst time of 5.
mm.
And then at t equals to 8, no, t equals to 9, P1 is finished is executed at 9. So it
Yeah.
will become P2 of 2,
Mm,
P4 of 3,
mm,
P3 of 4,
mm.
P5 of 5. And then since this guy is returning from the CPU, he will stand at the last, which is
P1.
P1. And how much is left? P1, if you see, it had
P1.
2.
Mm.
No, 5, right? So 5 minus 3 is 2. Yeah,
No, why 5? 3 minus 3, 6, sorry, 8 minus 6, right? 2, 2, so, sorry, sorry.
2 to 2. 5, no, here.
Ha,
This
ha, ha. Ha, 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 correct,
Just be
correct.
careful with these numbers. And then now all the processors arrived at t equals to 9. Okay.
Mm, mm.
Now you can do the normal round robin. So the order will be 2, 4, 3, 5, 1, 2, 4, 3, 5, 1. Let's do that. So let's see.
Okay.
So at P2, P2 has only 2. So 9 plus 2 is 11. And then P2 is executed, done.
Mm,
And then next we have P4.
mm.
P4 has 3. So 11 plus 3 is 14. And this is also executed. Then we have P3 of 4. So P3 will execute for 3 since the time quantum is 3. The 14 plus 3 is 17. And 1 will be left for that. So we have to take that next time. And then we have P5. So P5 will execute for 3 again. This becomes 20. And P5 had a burst time of 5. So 2 will be left for that. And then P1 will be executed with, it has 2. So 20 plus 2 is 22, and P1 is also done. So what is left right now? P3 and P5 are only left. So we'll again take P3, and it has only 1, so 23, and P3 is also done. And then last one, P5, and it has only 2, so 23 plus 2 is 25, and this is also done. That is a round robin.
Mm. Okay, got it, got it. So now it is clear. Now I got it properly. It's a little bit confusing at the first, but then it's all fine. Ha, done.
So this is round robin, and that's it. That's with your all your algorithms. Just
Oh,
practice this one well. Practice
mm,
this one more time. Take some other question and try to do it.
mm. Okay. Are share me
And
your
then say the
PDF.
calculations are the same again. I'll share this PDF. And then one last topic we have is this
Mm.
one: multi-level queue scheduling and multi-level feedback queue scheduling. So what happens here is you have, instead
Okay.
of only using one algorithm, you will use multiple algorithms. So how does it work? For example, let's take which one? Which should I take? It's for the quantum 8 and 16 is basically round robin of 8 and 16,
Okay.
then FCFS. So let's see.
Okay.
Let's do P1, P2, P3, P4, P5, P6, P7. And let's say the time the arrival time, let it be, um, let all be 0. So let all come together. It's fine. And then we can do burst time. Let's say this is 20, this is 8, this is 8 again, and then this is 10, this is 2, this is 1, and this is again 8. So wait, you know what, let's
Mm.
do 8 plus 16 is 24, right? Let's do this one 24. So how will you do? First one, we have to do round robin of time quantum 8. So this is a Gantt chart, and then you will start with P1. So P1 0 2, because time quantum is 8, we will take 8.
How?
Hmm.
Let me.
Yes.
Like, how do you like understand that you gotta do quantum of 8 first and
See
then
now,
quantum of
it's
16?
starting
Like,
from
will they
this here.
specify?
It will be specified. So you see this diagram, right? This
Yeah.
diagram is this, like something like this will be given. So it starts with the arrow of this first. Then, if it is not finished, then it will go to 16. And even if 16 doesn't finish all this, then it goes to FCFS. So I'll show you how that works. So let's see. Let's first we're starting with round robin of 8. So first P1 will be executed for 8. 20 minus 8 will be 12. And then we have P2, and this goes for 16, and P2 is executed. And then P3, again this is 24, and this is executed. Then P4, this is 32, and this 24 minus 8 is 16. And then we have P5. P5 is only 2, so we can take 34, and this is also executed. Then P6, 1 is there,
Mm.
35, this is executed. And P7, This is 8, right? So 8 will be the maximum. So 35 plus 8 is
Hmm.
43. And this is also executed. So one full round or round robin is over, right? Hmm? One round or round robin is done, right? From P1 to P7. Now what will we do is,
For
since one round is done
quantum 8,
and we have other levels also, we'll now do with
right?
8 is done. So now we'll do for quantum 16. Hello?
Hmm.
Hello?
Hmm.
Can you hear me? Ha ha ha.
My voice is lagging.
Now you're audible.
Hello. I don't know why. Like I said something like around 30 seconds ago, is reaching you after 30 seconds.
Okay, so Meka Veka is having some internet issues. It's past 12:30, but yeah, I'll finish this. So what happens is now you have time quantum of 8 is done. So now you have to do time quantum of 16. So time quantum of 16, that means the maximum will be 16. P1 only 12 was left, so this becomes 0. P1 is done. And then we have P2 was already done, P3 was done, P4 is there, that has 16. So this will again become 0, and 16 is basically um, 71, I guess. Yeah. And that is also done. And if you see, all the process are done. In case we didn't have we had any other process, we would have done that in this round robin. And even if that didn't finish it, we would have done with FCFS. Yep, that's about it. And you can take a screenshot of this, and you can try to do this on your own. Maybe take another example. But yeah, that is the end of this lecture. I hope you learned a lot, and sorry so that you had to bear through the network issues and voice lags. I'm not gonna edit it out because it takes time. I might do it later on. Yeah. Thank you. Bye bye.